Hi guys.
Hello, ma'am.
Is Can we start?
Yeah, we can.
Okay. So now that we're done with algebraic functions, we're going to be doing trigonometric functions. Yeah.
Yes, ma'am.
And then this one only has 3 graphs: the sine, the cos, and the tan graph. So today we're going to be doing the sine graph. Yeah. So I'm going to be going through the graph, what it looks like, the shape, and then things like the domain, the range. And then this graph has something called a period. So we're going to be going through all those things like we did with algebraic functions. Yeah.
Yes, ma'am.
Mm-hmm. Are you the only one in this class? Why is everyone else quiet?
Maybe they don't want to talk, ma'am.
Please ask Felicity and Bali to connect their audio because they can't hear me. If audio is not connected, they can't hear me. Kosi, please text them in the group. Kosi.
Yes, what's going on?
Please ask Felicity and Bali to connect their audio because they can't hear me if their audio is not connected.
Oh, okay.
Okay, so the sine graph, let me see if they're connected. They're still not connected. Okay, but it's phambili. Okay, so both the sine graph and the cos graph now, graph look like waves. The only one that's different is the tan graph because it has asymptotes, but we'll discuss it when we get to that graph. Now, I think trig functions are pretty much simple because most of the time you're just going to be using a calculator. Now, but for a standard sine graph, now, y equals to sine theta, now, usually starts from 0, as opposed to the cos graph, which starts at 1. Ne? So a standard y equals to sine theta graph without any moderations will start from 0. Ne?
Yes.
If your period is from 0 to 360, so if your Cartesian plane is from 0 to 360, it will start at 0 and end at 360. Now, it will start at 0 on the dots and end at 0. So it will start at y equals to 0 and end at y equals to 0. Ne? And then the reason why I'm saying this graph is simple is because you will use standard angles with intervals of 30 degrees. Ne? You can even use a wider range. You can use intervals of 90 degrees. Ne? And then it's simple because all you have to do is substitute the values inside a calculator and then to get your values for your graph. Ne? So as you can see with this graph, sine 0 is 0, and then sine 90 is 1, sine 180 is 0, sine 270 is -1, and then sine 360 is 0. Ne? It's a very simple graph. Ne?
Yes.
And then we have what we call a period. A period is how long it takes to complete one full wave. Those who do physics will know this. Ne? One complete wave is how long it takes to, a period is how long it takes to complete one full wave. Ne? So if you know what an amplitude is, okay, the amplitude, let me explain that. Amplitude is this. It's from the x-axis to the highest point in the graph. That's what we call an amplitude. Ne? So
Yes,
basically, a period can also be defined as how long it takes to complete two full amplitudes. Ne? So like I said again, amplitude is the maximum height of the wave. So from the x-axis to the highest point in the graph. Ne? That's what we call an amplitude. And then we always make it positive. Ne? Your amplitude is always positive. So even here, even if here from here to here, from 0 to -1, you won't say the amplitude is -1. You have to say the amplitude is 1. Ne? Because the amplitude is always positive. I hope that makes sense.
Yes.
Yes.
Okay. And then remember the domain is again the values that the graph has. Ne? I explained this when we're doing algebraic functions. So if our graph was like this and started here like this from -180 to the side to +180 to the side, ne? Then your domain was going to be from -180 degrees to 180, both included. Ne?
Yes.
Yes.
Yes. And then remember your range is your y values that are covered by the graph. In this case, from 1 to -1 or from -1 to 1, ne? Both included. Ne? So remember, you can also write it as for domain, you can also write x is greater than 0 included, but less than 360 included. Degrees. Remember. And then for range here at the bottom, you guys can also say y is greater than or equal to. So y is greater than -1, but less than 1. You guys can also write it in that way. Ne?
Yes.
You guys have any questions so far? guys have any questions so far?
No.
Okay. And then for intercept, it's easy. You can just look at your graph. You can see the graph crosses the X and the Y axis at 0. And then it crosses the X axis at 180 and at 360. Ne? And then it crosses the Y axis at 0. That's it. Okay, so let's do an example before we cover graphs that have things added extra onto it. Nem. So let's do 3.1. This one. So if you can quickly calculate the values for sine minus theta from 0 to 360. I'll give you guys 2 minutes and then we'll draw the graph. Okay, guys, ready to answer?
Yes.
Okay, Nomvula, sine negative theta. Okay, you can fill in the rest of the table.
Mbuhle, Butle.
Okay, you can leave out 60 because it's going to be a number with decimals. Thank you. So if we draw a graph, and we have 1 here and -1. I'm just going to do 90, 180, 270, 360.
Ma'am, are we not calculating the one
Hey.
with negative?
Yes, we are. What is the problem?
Oh, so we're going to the left, ma'am, not to the right.
No, we're not. You understand why?
No, I don't understand.
Okay, so what happened is that we just reflected the graph. Ne? We didn't shift it, we reflected it about the x-axis. Ne? Because there's a difference between negative sine theta and sine negative theta, sorry. So we just reflected it about the x-axis. So when you put the values in your calculator, what do you get? Do you get a different answer from the ones Nomvula got?
No, I got the same answers.
And then when you plot them, what kind of graph are you going to get? You still get your 0, right?
Yes, ma'am.
And then 90 is now -1 instead of 1. Can you see how we reflected the graph? I'll draw the original just now, and then I'll draw this one so you can see the difference. 180 remains 0. 270 is now +1. So now we get a graph that goes like this, whereas the original graph looks like this. Can you see the difference?
Yes.
So
Yes,
now it
ma'am.
just looks like we took a mirror, and then what we see on one side, it just got reflected, basically. That's what we did. Does it make sense?
Yes, ma'am.
So any questions? Any
No.
questions? Is anyone having difficulties understanding? Is it Kuma who just joined us? Okay. Does anyone have any questions? Okay. So now we get to our P's and Q's and how they affect the graph. Now remember, we also did the same thing with our quadratic functions. Ne? So here we have A and we have Q. Ne? So Q, once again, we know Q always affects the Y. How the graph shifts about the Y-axis, and this is no different. So even here, it does the same thing. Even here, it does the same thing. Ne? So when Q is greater than 0, ne? So when Q is positive, yeah. So when Q is positive, the graph shifts upwards. So if now we have sine theta plus 2, the graph will move 2 units upwards. Next. So now instead of the amplitude being at 1, the amplitude will be at 3. That does make sense. I hope I'm making sense.
Yes.
I'll make an example just now. And then when Q is less than 0, so when Q is negative, so if we have sine theta minus 2, the graph is going to shift downwards by 2 units. Ne? So now instead of the amplitude or the lowest point being at -1, the lowest point will now be at -3. Ne? So let's see what that would look like on a Cartesian plane. So if this was a Cartesian plane, (90, 180, 270, 360. One, two, three. -1. Negative. So once again, I'm going to draw the normal graph. And then now, if we have sine theta plus 2, we're going to have it's going to look like this. And then for sine theta minus 1, the graph is going to look like this. So can you see how Q affects our graph?
Yeah.
Do you guys have any questions? Do you guys have any questions regarding Q and how it affects our graph?
No.
Are you guys sure?
Yes.
Okay, so now we move on to the A. Next. So A affects the amplitude, and either by stretching the graph or narrowing the graph. Ne? So it will change the amplitude. It will either go higher or lower depending on what A is. Ne? So when A is positive, so greater than 1, positive, ne? The amplitude will increase. And then when A is between 0 and 1, so these are decimals. So this could be 0.1, 0.2, 0.5, 0.65, 0.7, any number that's between 0 and 1, ne? The amplitude will decrease. And then when A is less than 0, then it will be reflected the same way when we have sine theta in a bracket. So there'll be a reflection. Does it make sense?
Yes, ma'am.
Okay, who said no first before I explain? Is it Kuma?
No, ma'am.
Who said no? They don't understand. Okay. So you'll see in your calculator, if you put in sine theta and negative sine theta, you'll get the same answer. Because in trig, what you do is when you have, even when you're solving trig equalities, I don't know if you guys have done this already, like solving trig problems. When you have this in trig, when you have sine negative theta, you can always take out the negative, put it in front of the sign to help you solve the equation. I don't know if you guys know this. Have you guys done trig already?
Yes, ma'am.
So is what I'm saying making sense?
A bit, ma'am.
Yes.
Even if you put it in your calculator, if you put sine minus 90 and minus sine 90, you'll get the same answer because they are the same thing. And then remember when we drew this, the graph that looked like this, we had a reflection about the x-axis. Remember?
Yes, ma'am.
So the same thing here. So if this gives you a reflection about the x-axis, even here when A is negative, you get a reflection about the x-axis because these two are the same thing. I hope that makes sense.
Yes, ma'am.
And then when A is between -1 and 0, so we're here. So if it's -0.1, -6.6, 0.66, -0.2, you'll get a reflection about the x-axis and you'll get a decrease in the amplitude. Né? So I'll try to explain all of these things using graphs right now. And then when A is less than -1, there's reflection about the x-axis and the amplitude increases. I hope that makes sense. So we draw the graph again, the original graph. Okay, so I'm going to draw the original first. So 0, 1, 0, -1, 0. Okay, someone give me, so let me write that this is Nomvula Nkrumah.
Yes, ma'am.
One of you guys is disturbing us.
It's true, my man.
It's not me.
Oh. Okay. So Nkrumah, give me a sum where A is, let's see. Where A is less than 1. Or greater than 1, sorry, where A is greater than 1. Nkrumah.
I should give you any number.
Yeah, any formula where we have sine theta, but A is greater than 1. But don't make it too big, because we have to draw the graph.
Okay, ma'am. Can I type?
No, you can just say it. Okay, let's say 2 sine theta.
Yes, ma'am.
Okay, so 2 sine theta. We have 0. So you can see once again, same graph, but because our A is greater than -1, we have a high amplitude. So let me write here 2 sine theta. And then if we have 0.5 sine theta, okay. Yo, guys, don't get confused between my 0.5 and my S. I hope it's visible.
Oh,
So for 0.5 sine theta, does make sense.
Yes, ma'am.
Yes, ma'am.
yes, ma'am.
Okay. And then now once we get to the negatives, right? So if now we have okay, we just carry on. I don't know where the others are. So that's what I'm doing. And then Konje Scoopy. Oh, so we're just now going to reflect the two graphs. Ne? Okay, wait, I forgot to write the formula for this one. 0.5 sine theta. And then here we have negative, I'm going to do -2 sine theta and negative 0. Negative 0.5 sine theta. This is the piece that you cannot find. I think you cannot see. The price that you cannot. Okay, so can you see that when A is positive but greater than 1, sorry, let me just let people in. Okay, so when A is positive and greater than -1, so in this instance, I used 2, our amplitude increased, right? As seen by the yellow graph. Ne? And then when our A is still positive, but between 0 and 1. So for example, I used 0.5, ne? Our graph, our amplitude or the amplitude of our graph decreased. Ne? And then when our A is negative and greater and less than -1, sorry, and less than -1, in my example, I used -2, right? I got a bigger amplitude. So my amplitude increased, right? But it was reflected about the x-axis. So if you look at the red graph and the yellow graph, they are the same thing, but just reflections of each other. Ne? The yellow graph is the positive graph and the red graph is the -1. Next, the reflected one. So again, when your A is greater than 1 or less than -1, your amplitude will increase, but one will be the reflection of the other. I hope that makes sense.
Yes.
If it doesn't, please say now so I can try to explain better.
Ma'am,
Yes,
can you
Yebo.
explain again?
Okay. So, can you see the yellow graph? Okay, can you see the
Yes.
black graph? The black graph first. Ne? So
Yes,
the
ma'am.
black graph is the original sine graph. It's the original. Ne? So let
Yes.
me try to make it thicker. So this graph, the thick black graph, right, is the original graph. Ne? And everything else is an alternate or an altered version of it. Ne? So
Yeah.
the black graph is just simply sine theta. Oh, let me change that. The black graph is simply sine theta. Ne? And then all the other graphs, I've written their equations according to the color. Ne? So we are looking at A, and A is the number in front of sine. Ne? A is always the first number, the coefficient of sine. Ne? So with the yellow graph, the coefficient is 2, right? So I drew this graph. What I'm trying to show you is that according to the rules, as I said to you, when A, which is the coefficient of sine, or the first number that appears before sine, when it's positive, right, and greater than 1, you will see your amplitude increase. And remember, the amplitude is the space between the x-axis and the highest point in the graph. So can you see, for the thick black graph, our amplitude is 1. So the distance from here, from the x-axis to the highest point in the graph, is 1. However, for the yellow graph, it has increased to 2. Can you see?
Yes.
So whenever you see your A is bigger than 1 and it's positive, then you know your amplitude will increase. Ne? And then let's look at the green graph. Ne? So the green graph also has a positive A. However, the A is between 0 and 1. Ne? So it's a decimal number. It can be anything 0.25, 0.67, 0.9, whichever number falls between from 0.1 to 0.99999. The amplitude will decrease, but it'll still be, so it'll still look like the original graph. It's just that now it'll decrease, as seen with the green graph. So you can see the green looks like the original. It's just that the amplitude is decreased or lower. The amplitude now sits on 0.5 instead of 1. Does it make sense?
Yes, ma'am.
Yes. And then now looking at negative A. So when A is negative, right, and it's less than negative 1. Remember, the higher the number on the negative side, the less it is. So negative 16 is smaller than negative 1. Do you agree?
Yes.
Yes, ma'am.
Does make sense? Yes. So whenever a number is less than negative 1, right, when your A is anything that is negative 1 and less, né, your graph will be a reflection, right? Can you see now with the red graph, right? It's reflected, right? And because now the number is less than negative 1, the amplitude also increased. So now, basically, the red graph and the yellow graph are the same graph. It's just that they're reflections of each other. It's basically the same thing. It's just that one is a mirror image of the other, né? Because one is positive, one is negative. Né? So what you will see, even if we just had negative sine theta, we're going to get a reflection. Even if we just got a negative 1 sine theta, we're still going to get a reflection of the original graph. Né? So as you can see with the red graph, which is, so when A is negative, the graph gets reflected and then the amplitude will either increase or decrease. Né? If the number is between 0 and negative 1, so negative 0.3, negative 0.4, in this instance, I used negative 0.5, the graph will be reflected and then it will decrease. I hope that makes sense. It will be reflected and then it will decrease. And then if it's anything from negative 1 to negative infinity, it will also be reflected and the amplitude will increase. Ne? So basically with the sine graph, let me teach you a trick. With the sine graph, ne, your amplitude ne, is always the value of your A. So can you see in this original graph, the black graph, what is the A there?
It's 1.
It's 1. And what is your amplitude?
It's 1.
1. With the yellow graph, what is your A?
It's 2.
2. What is your amplitude?
2.
2. Correct. So whenever they ask you for the amplitude with the sine graph, just look at A value and your A value will be your amplitude. And one way you can also remember it is amplitude starts with an A. So A value, amplitude. I hope that makes sense. If you look at all these graphs, you're going to see that same pattern. I don't know if you can see it. For the red graph, our A is negative 2, but remember I told you amplitude is always positive. So our amplitude will still be 2. Same thing with the blue graph, right? Our A is 0.5 and our amplitude is meant to be 0.5 as well. Does it make sense?
Yes.
Yes.
Yeah. Do you guys have any more questions? Do you guys have questions?
No.
Are you sure?
Yes, ma'am.
You guys must interact with me now, because I don't want this to be like you guys are sitting in a classroom listening to a teacher at school, because you guys already have that. Ne? So this is meant to be different. You guys are supposed to ask questions, say when you don't understand. Ne? I want you guys to engage with me, because I don't want it to be a boring one-way conversation, because obviously you're gonna get bored, you're gonna get sleepy, you're gonna yawn. You already come back from school, you are tired, and now you have to sit in front of your phone or your laptop or whatever. I don't want it to be boring. So you guys must engage with me. And if you feel like you wanna try the sum, you can tell me I want to be the one to answer this or whatever, and then I'll give you the opportunity there, because we're all here to learn.
Yes, ma'am.
Yes. Okay, I had like questions lined up, right? But I had questions lined up, but most of them are a mixture of two graphs. So we're gonna cover the sine graph tomorrow, and then after that we will attempt questions from, yeah, because can you see this one has the sine graph and the cos graph. And then I think I had other questions as well. Also, this one has the cos graph and the sine graph. So I'll do the cos graph tomorrow, and then we'll answer these questions from past papers. You guys have any questions? This is the time graph. Yeah. You guys have any questions? So this is another example of what I was showing you guys right now, but I just felt like it was going to be easier for me to draw and show you what I'm talking about. But I hope it makes sense. I also sent these notes to you just now. Do you guys have any questions?
No.
Okay. I'll see you guys. Your next lesson is on Thursday.
Or tomorrow I'm not learning.
No, tomorrow's the Maths Lit people.